Welcome to the questions and answer series for Windows Communication Foundation, or in other words, we can say WCF. And let us start with question number 1. What is SOA, services and messages? The first thing which you must be thinking is that why are we discussing about SOA when the questions and answers series is for WCF, that is Windows Communication Foundation. In today's world, in today's IT world, especially in IT projects, SOA has come up as a very accepted architecture because of its loosely coupled style, loosely coupled messaging, etc. So every programming language, for example, it is Java or .NET, they try to cater to the SOA style of architecture. And definitely Microsoft also needs to do something so that his programming community can benefit from SOA. So WCF is a methodology, or WCF is a technology. It's not only WCF, basically we also have WWF, that is Windows Workflow Foundation. So using WCF and WWF, you can build up a SOA style of architecture. So what we'll do is that we'll first discuss about SOA, and then we'll see that how we can use WCF to implement SOA. Before we start to discuss about service-oriented architecture and its principles, what we'll do is that we'll move back to 1980s, where people talked in terms of functional programming. So people coded in terms of functions, and basically they also put down some best practices like top-to-down approach. So in other words, always the entered function, like example, take input is an entered function here, which is the first entry point. So if it's calling add number, then it should call in a waterfall fashion, and the add number should again pass back the control to the main function. So in other words, no function should hop in between using goto or etc. Always go in a top-to-down fashion. Then the other best programming practices laid down was like don't code too big functions. Basically code them in a logical manner so that it can be maintained. So etc. etc. Everything was good in functional programming era. I think some of the best IT applications were made in those era, and they are still alive today. But there were two big issues with functional programming. First was maintainability, or I can say rather, understanding somebody else's code. For example, if I take up an old COBOL code or a C code, and if I want to understand that program, it was really difficult because everything was in terms of functions. So you cannot really map to the real world and try to understand that what's happening. That was the first problem. The second problem was reusability. It is not the point that reusability was not there. For example, if you take up a C program, or if you take up a C language compiler, you can reuse a function by putting that into a C file and then using the include keyword. But then it was a physical include. So in other words, you need to include the whole file into the main source file, which needs to basically reuse that program or the function. So the reusability thing was not so flexible, and the first important point was maintainability. So people moved towards 2000, people moved towards 90s, I'm sorry, and reusability was the agenda, and people came out with something called as object-oriented programming. So people said, or I'll say the IT programming community said, let's talk in terms of objects of real world. Let's talk in terms of let's try to map our source code with the real life objects. So with that we can maintain our source code, we can give a proper handover to the new programmer. So people started thinking in terms of classes and objects. So basically you can create a class and then reuse the class again and again, you creating objects of that class. So for example, I can create a customer class and reuse it again and again, creating creating objects of the customer class. Everything was well in 1990s, but one of the point which they forgot to think about was that the classes also need to interact outside the application. So for example, you can make a class in .NET, but if you want to call that class using Java, it was very difficult because every company, like example Microsoft, like .NET belongs to Microsoft and Java belongs to Sun. Okay, so everybody had their own proprietary way of compiling programs, and due to this, it was very difficult to call classes made in one language into other language. So people said that definitely this is a problem, and they said let's think in terms of messages. So then came 2000 style of programming, I'll say the 2000 era, where people said, let's not talk in terms of classes, objects, or proprietary compilers, etc. Let's talk in terms of messages. Now these messages can be in form of XML or in form of CSV, etc., whatever it is. We'll come to that later and see that how these messages are standardized in today's industry. So basically, probably .NET, if you want to call up a .NET function, or if you want to create a .NET voucher class, so the Java application can send the XML message, okay, and .NET can read that XML message and create an object of the voucher class. So with this came in loose coupling. So now either .NET or either Java don't need to think in terms of their proprietary compiling methodology or their objects or DLLs or classes, but they need to only think in terms of messages. And the programming industry decided that let's do one thing, let's take up these messages and make them more standardized, so that we can interop between any programming language. One more thinking change other than the messages which we need to bring in is thinking in terms of services. So let me first define services. Services are nothing but their logical encapsulation of self-contained business functionality. This is a very important part. Services are self-contained business functionality. For instance, here I have three services: counter, kitchen, and a waiter. Okay. Now, basically, I can take up the kitchen and attach to a one room bedroom, okay, or I can take up the kitchen and attach to some hotel room, so to some hotel. So in other words, the kitchen is a self-contained functionality. Second, I can change the kitchen without even thinking about the waiter, or I can replace the waiter with some new waiter without even changing the kitchen look and feel, or without even changing the kitchen structure. So in other words, the other aspect of the self-contained functionality should be that we should be able to change and modify those services without even affecting the other services in an isolated manner. So basically, on a totality, we can say that, okay, we have services and we have messages which help us to communicate between the services. Now, very important point to remember here is that services are not classes and components, right? So that is a very thinking shift which we need to bring in, which we need to bring from the object-oriented perspective. Services are not components, or services are not namespaces, or services are not group of classes, but they are self-contained working business functionality. In order to keep this video small, I have divided this video into two parts, so that people can download it, and this same thing I have continued in the second part. So please see the remaining part of SOA in the second part of video.